Very much. Alright, so we continue back to our discussion. Okay. So here, example 1. Okay. So there's a mass here. Okay, the mass is just like this. Alright. So the question is, okay, an object of mass 20 kg. So we consider the object is 20 kg. Maksudnya dia punya jisim dia adalah 20 kg. Okay, inclined plane. Coefficient of kinetic friction given to you. Okay, mu biasanya dipakai mu saja. Okay, 0.2, 0.2. Alright. What is the horizontal force F to keep the object not slide down in the climb? Okay, that means how much force, okay, needed, okay, in order to make sure the object is maintaining ataupun tak bergerak. Okay, the force acting. Okay, either friction or force. So friction and force must be equal in order to the object is maintaining the position here. So free body diagram, you kena lukis dulu free body diagram here. Okay, so it's W. Next one, here W, Y, here is WX. Okay, next one, here is theta, the angle here, and then there's a normal reaction acting. Okay, and then the object should be slide down, but there must be a force acting that avoiding the object to slide down. Okay, so there must be a force. So dalam kisah ni ataupun dalam case ni, in this condition, so friction is pointing the main roles. Okay, ataupun adalah penyebab utama disebabkan objek ni tidak bergerak. Okay, so how to do? Okay, so in order to do this, okay, so make sure we can do in two basic components. Okay, so the first one, we have to analyze the x component first. Okay, right, we do for the x component first. X component for the object, okay, summation of all forces acting on Fx equal to ma. Since the object doesn't move, that means there is no acceleration, and then there's no velocity here. Okay, so we consider the object doesn't move, so the acceleration is 0, so equal to 0. Okay, so the object is stationary, maksudnya objek ni tetap kekal. Okay, bergerak ke atas pun tidak, bergerak ke bawah pun tidak. Okay, so dia tetap kat situ ataupun tidak bergerak. Okay, so kita nak buat the main solution. So the first one, force acting downwards and upwards. Yeah. Okay, this line we consider an x component. Okay, this line maksudnya parallel line ni, okay, kita consider sebagai x component ataupun certain book is used here is parallel component. Okay, parallel component. Okay, parallel component. So fx, so downward. Okay, downwards sama juga wx. Okay, wx pointing downwards here. Okay, wx. Okay, disebabkan dia berat, berat akan pointing downwards. Okay, so wx and then minus. Okay, minus w, sorry, this one, friction. Okay, dia akan tolak dengan friction. So bila tolak dengan friction pada component, so dia akan jadi, okay, so this friction here, so there is a friction here. Okay, next one, okay, CWX. So we want to find another force acting on the objects. So how much force is acting on the object? Okay, how much force is acting on the object in order for the objects to remain stationary. So ada force kat sini. So berapa banyak force yang acting kat sini? So the force acting here should be in x direction. So bila kata x direction, dia mesti ada angle dekat sini. Okay, so bila angle kat sini, so you boleh masukkan fx adalah sama juga dengan f cos theta. Okay, f cos theta. So the angle is equal to here. Okay, angle kat sini sama dengan angle kat sini. Okay, so minus F cos theta. Okay. Okay, dalam kes ni, theta diberi, okay, inclined plane diberi adalah sama juga dengan 30 darjah. Okay, 30 darjah. So, Wx minus F cos theta is equivalent to 0. Okay, since the object is stationary. Okay, so we know that Wx, okay, so kita dah bincang tadi, Wx, you can see here. So, Wx is equivalent to W sin theta. Okay, so Wx equivalent to W sin theta minus F cos theta. So equal to 0. Okay, equal to 0. Okay, so we can calculate. Okay, the first acting. Okay, the first one here. So W is 20 times 10. So we are using G, gravitational acceleration equivalent to roughly ataupun menghampiri 10 meter per second square. Okay, supposedly G is equivalent to 9.81 meter per second square. So kita gunakan 10 untuk memudahkan pengiraan. So 20 multiply by 10, okay, sin 30, okay, minus F, okay, minus force here, F cos 30, okay, equivalent to 0 here. So we got the first equation, okay. So you got the first equation, okay. This one is for the first equation. So you can solve this one, okay. Mg, okay, Mg sin 30, okay, and F cos 30 dekat sini. So you boleh solvekan jugalah, okay, dalam persamaan. So this one is the first equation, okay, the first equation. Next one we go for y component or vertical component. Y component ataupun vertical component. So vertical component. So for the vertical component here, okay, summation of all forces acting on y-axis, okay, equivalent to MA. Since the object doesn't flying, doesn't jumping, so it's remain there, okay, remain stationary, so it equivalent to 0, okay. So Fy, so Fy here, n is positive, pointing upwards, so you can put it here, and positive minus, okay. So the downward here, okay, in line with the n is Wy, okay, so minus Wy, so equivalent to 0, okay. So we can say that, oh sorry, another one, I'm forgetting about this one, okay. So since this one is F, okay, it have, okay, the first one is X component, and F also create what we call F, okay, forcing acting to Fy. So Fy here can be calculated, okay. If Fx is cos, so Fy is F sin 30, okay. So for sin 30, so we can put here, this one is the first one, W, pointing downward, okay, vertical. This one is N, pointing upwards. And then there's another force acting due to the force acting, okay, here. So Fy is pointing downward. So we have to make some correction here, okay. So N is pointing upwards, become positive, okay. So Wy pointing downwards become negative, and Fy here is pointing downward, so become positive. F sin 30, okay, so equivalent to 0. So from here you get another n is equivalent to, so you can calculate here, okay, n is equivalent Wy, so n is here minus Wy is equivalent 20 multiplied by 10, okay, Wy here, okay, since Wx is sine, so that means Wy is cos, okay, so Wy is cos, so put it here, so cos 30, okay, minus F sine 30, okay, equivalent to 0. Equation number 2. So since you got two equation here, so you can solve for F and N, okay. You ada dua equation kat sini, you boleh buatkan persamaan, sama ada you selesaikan secara persamaan serentak ataupun gunakan penggantian, teknik penggantian, ataupun satu lagi kita panggil kaedah matrix. Okay, so ada 3 kaedah lah untuk maths yang kita nak solve macam mana. Okay, so daripada situ you boleh juga gantikan dalam persamaan. Okay, so kat sini boleh gantikan dalam persamaan, you gantikan nilai n tu sama dengan apa. Okay, so contoh dia, okay, kita buat solve lah sampai habis. Okay, so nanti saya akan bagi jawapan lah. Okay, so from here, okay, we can say that, okay, f here is equivalent to, bring it here, so f is equivalent to 200 sin 30 minus f cos 30. Okay, equation 1. Okay, so f is here equivalent to mu n. Okay, f is equivalent to mu n here. So f equivalent to mu n, 200 sin 30 degrees minus f cos 30. Okay, so kat sini ada mu dengan n. So kita nak cari f. Okay, so kita nak cari nilai f, force here. So we want to find the force. Okay, so we can take out here, n is equivalent to, okay, so is n equivalent to 200 cos 30 minus f sin theta. Okay, so n is equivalent to 20. Okay, we can put it here. So n is equivalent to 200 cos 30, okay, plus f cos 30. Okay, so from here, so put inside here. Okay, n, masukkan n kat sini. Okay, so you boleh dapat nilaian dia. Okay, mu n, mu pun you dah ada, mu sama dengan 0.2. So you boleh masukkan dalam persamaan kat sini. So persamaan ni akan jadi panjang sikit. So mu n, so kat sini akan jadi 0.2. Okay, multiply by 200 cos 30 degrees plus f cos 30. Okay, equivalent to 200 sin 30 degrees minus f cos 30 degrees. Okay, so you can solve, then rearrange the equation. Okay, f dengan f kat sini, rearrange, dapatlah f kat sini, nanti keluarkan f, okay, sebagai perkara rumus. Okay, so daripada f kat sini you akan dapat jawapan 66.4 Newton. Okay, ini adalah jawapan dia. Okay, okay, yang ni you try solve. Okay, you can discuss. Okay, you can refer to your maths note. Okay, I won't elaborate panjang sangat lah. Okay, on this one. Okay, you just kembangkan. Okay, you multiply here, and then you multiply here, and then rearrange the equation lah. Okay, then take out the f. Okay, jadikan perkara rumus. Okay, dapatlah f sama dengan 66.4 Newton. Okay, ada soalan ke setakat tu? Sir, N is stand for normal force ke? Yes, normal reaction Haris. Okay, normal reaction ataupun normal force lah. Okay, so yang tu basic dia. Kalau tengok kat sini, yang mana melibatkan N must be here. Okay, normal reaction due to Newton's third law. Okay, bila ada weights pointing downwards, they must be equal and opposite direction. So W, Wy here, so there must be a normal reaction N lah. Okay, setiap objek yang ada dekat mana-mana surface ataupun permukaan. Okay, okay, if there is no additional question, so we continue with another example. Okay, for another example, example 2. Okay, for example 2. Okay, the situation is just like this. Okay, okay, untuk contoh-contoh yang lain, you boleh refer kepada yang kita panggil sebagai e-books. Okay? Dekat dalam e-books yang saya sertakan, dekat e-learning pun ada contoh-contoh berkaitan dengan inclined plane. So based on this class, hopefully you can understood and you can apply, and then you can refer back to your e-books. Okay, this situation is just like this. So there's A here, and then there's a B here. Okay, and then both box MA is equal to MB equivalent to 30 kilogram. So logically, A and B, so B will pulling A downwards. Okay, sebab apa? B akan secara logiknya akan menarik A turun ke bawah. Okay, so mu given here 0.2. Okay, 0.2. Mu tak ada unit lah. Coefficient of friction tak ada unit, dia just perkali saja. It's just a numbers, right? Calculate the acceleration of the box and the tension in the cord. So dia suruh cari acceleration A of the boxes, okay, and then the tension between the rope here, okay. So ada soalan kat sini. So we can write it, okay. First step, kena buat free body diagram. So mass A akan ada dia punya berat WA, and then there must be another force acting opposite in direction, Newton's third law. We call it normal reaction, okay. So there's a pulley here, so T is pointing here, okay. Tension akan pergi ke arah tengah, so tension pun akan pergi arah ke tengah, and then there must be a friction, okay, arah ke sana. Sebab apa? Objek ni akan bergerak ke arah bawah, okay. Sebab apa? B akan menarik, okay. So dia punya acceleration adalah sama antara A dan B here. So there must be a friction here, okay. Next one, okay, W here, so WB, right. Next one, there must be WY, okay, and WX, okay, WX and WY here, right. So the angle here theta, and then there must be a normal reaction for the second mass ataupun mass B. Okay, that's it. Okay, then we can consider, okay, since the object is involving two different masses, same masses but there is two mass lah, maksudnya dia melibatkan dua objek. So we have to consider the first A first, right. So we have to consider and then solve for A first, okay. So mass A, okay, so for mass A sama juga macam kelas sebelum ni yang melibatkan punya gerakan, cuma kat sini akan melibatkan paksi condong, okay, yang melibatkan paksi condong ataupun inclined plane, right. So mass A, so the angle here theta is given 30 degrees, okay, suka, okay, 30 darjah ni, right. So mass A, summation of all forces acting on X equivalent to MA, okay. So since there is the acceleration here, so A ni berfungsi lah, maksudnya A ni berfungsi, so dia akan bergerak lah, okay. So next one, so F1, so the force acting, okay, dia akan melibatkan kepada dua. Fx, so Fa kat sini dia akan melibatkan T, and then F ya, akan melibatkan kepada dua. So T pointing this way minus F, okay, next one is MA, right. So T tak tahu berapa, F sama dengan mu N, okay, melibatkan mu N, MA 30 kali dengan A, okay. So N here must be come from Fy, sama juga dengan MA, since the object doesn't fly, doesn't move, doesn't jump, so it's equivalent to 0 here, okay. So Fy kat sini akan ada positive N and negative omega A, WA. So N minus WA sama juga dengan kosong. So N sama juga dengan WA, so N sama juga dengan M kali G, okay. So 30 kali dengan 10. Okay. Sama juga dengan 300. So kita gunakan G, gravitational acceleration, roughly menghampiri kepada 10 meter per second square untuk memudahkan pengiraan. Okay. Standard, you kena guna 9.81. Okay. Okay. Yang ni untuk contoh saya gunakan 10 lah. Okay. So N numeration ni sama juga dengan 300 Newton. Okay. Ini N. Okay. This one is N. So here you can calculate. So T is equivalent to minus 0.2 multiplied by 300. Okay. 0.2 multiplied by 300. Yeah. Okay. Equivalent to 30A. Okay. So T minus 50. Maksudnya 300 bagi dengan 5. So you akan dapat 60. Sama juga dengan 30A bersamaan dengan 1. Okay. First equation. Next one. Okay. For mass B. For mass B. Okay. So mass B. Summation of all forces acting on Fx equivalent to MA. MBA lah. Okay. So forces here. Wx and T. Okay. Wx and T. So Wx minus T. Next one. Another one is the friction here. So minus F. Equivalent to MB. MB is 30 times A. So A here is equal to A here. Okay, acceleration dia adalah sama. So Wx, you kena cari Wx. Okay, so Wx is equivalent to W. Is it cos or sine? Okay, so angle is here. Okay, it will become sine. Okay, so W sine 30. Okay, sine 30. So here W is equivalent to mg. Okay, sine 30. Okay, so W is 30 times 10. Okay, due to using G equivalent to 10 sine 30 degrees ya. Okay, so 300 sin 30. Okay, 300 sin 30. So you akan dapat lebih kurang 255. Okay, 255 Newton untuk Wx. So boleh gantikan kat sini. So 255 tolak dengan T, tolak dengan mu n sama juga dengan 30A. So mu n kat sini, n ni adalah melibatkan NB. Okay, yang ni adalah NA. Okay, so this one is NA, NA. Okay, numeration for A, this one is numeration for B. So numeration for B, summation of all forces acting on Y vertical axis, MBA here. Okay, so N pointing upwards equivalent to minus WY. Okay, equivalent to 0. Okay, sama dengan 0. Okay, so N is equivalent to WY. So WY, so this one is NB. Okay, NB equivalent to mg cos 30. Okay, so 300 here. 300 cos 30. Okay, this one is for NB. So NB is equivalent to ada mistake sikit. Okay, NA kita dapat kat sini lebih kurang 300. Yang NB, okay, yang sini NB you akan dapat lebih kurang, yang ni 300 kali dengan cos theta. So this one is 255 Newton. Okay, Wx ni bukan 255 ya. 300 sin 30. You boleh klik dia punya calculator untuk tekan sin 30. Okay, W sin 30. So you akan dapat 96. Sini adalah 96.18 Newton. Okay, so kat sini ada kesilapan. So sorry for this one. Okay, so Wx adalah 96.8. So 96.8 18 lebih kurang lah 97 lebih kurang kat sini. So gantikan dalam persamaan, and here masuk dekat sini. So you akan dapat satu lagi persamaan. Okay. So T is equivalent to 96.18, okay, minus T. Alright, so here equivalent to 30, okay, lebih kurang 30 A, okay. Alright, this one is for equation number 2, okay. After you get equation 1 and equation 2, then you can solve for both T and A. So, okay, jawapan yang terakhir, T dia akan dapat kepada 77.46 newtons, and then acceleration yang you akan dapat, jawapan dia adalah 0.62 meter per second square. Ini adalah jawapan untuk example ni. Okay. So, any question? No? No question at all? Okay. Okay, if there's no question, we go for the last example. Okay, example 3. Example 3. Okay, contoh yang ketiga yang melibatkan kepada objek. Inclined plane, same question. Okay, same question regarding inclined plane here. So there's a mass here, an object here. So the object is stationary. Okay. Can you figure out about the force acting on this object or friction that cancelling the force from the object to slide down? So please the diagram W here. So N is here. Okay, so there must be Wy, there must be Wx. Okay, and then next one there must be a friction. Then finish. That's it. Okay. So we can calculate, okay, the force that hold, okay, the friction that hold the object from moving downwards. Okay. So summation of all forces on X equivalent to MA, okay, equal to 0 since the object doesn't accelerate. So the object is stationary. So Fx is equivalent to F, okay, and then W, X is pointing here. So Wx minus F equivalent to 0 here. So Wx must be equal to the friction, okay, for the objects. So Wx is equivalent to, okay, the angle here, theta is here equal. So the theta given to you equivalent to 30 degrees, okay. So Wx is equivalent to mg, okay, mg sine theta. Sine theta equivalent to friction, okay. So mg, so the mass for the objects, we can put here the mass of the object is equivalent to 20, okay. Mass of the object is 10 kilogram. So we can say that 10 times 10. So we are using A equivalent or roughly 10 meter per second squared, okay. But if you do for the final exam and the test question, So you should use the gravity equivalent to 1.81 meter per second square. Okay, so sine 30, gunakan sine 30 equivalent to force. So force here, okay, mu n. Okay, mu n. So you can calculate the mu, the coefficient of kinetic friction that apply to both object. Okay, so n kat sini adalah sama juga dengan 100 sin 30 darjah bahagi dengan n. Okay, so in this case, okay, mu is equivalent to 100 sin 30 degrees divided by n. Okay, so summation of Fy Ma, okay, equivalent to 0, yeah. So n minus Wy equivalent to 0. So n is equivalent to Wy. So n equivalent to W1 equivalent to mg cos theta. So equivalent to mg cos 30, yeah. So m is 10 minus multiplied by 10 cos 30 degrees. So you get here is 100 cos 30. Okay, so n is here. So you can plug the value for n inside here. So what you get here, so 100 cos 30 degrees. Okay, so from this equation, okay, kita boleh summarize. Okay, so daripada equation ni kita boleh summarize yang mana mu adalah sama juga dengan 100 potong dengan 100. So ia akan dapat sin 30 bagi dengan cos 30. So perkali koefisien untuk satah condong boleh dicari dengan sin 30 darjah bahagi dengan cos 30 darjah. Okay, sin 30 darjah ataupun cos 30 darjah. Okay, and then kita tahu adalah sin bahagi dengan cos, you akan dapat tangent theta kat sini. Okay, so mu ataupun perkali bagi friction, okay, bagi satah condong adalah sama juga dengan tangent theta ataupun tangent 30 darjah. Okay, so ni adalah kesimpulan bagi satah condong, yang mana bagi satah condong kat sini ada nilai m. Okay, kalau you letak nilai m yang berbeza, you still akan dapat, okay, nilai mu yang sama. Okay, maksud dia you letaklah nilai m ni sama ada jadi 100 kg. Okay, okay, kalau you letak 100 kg pun kat sini, okay, you gantikan 100 kg kat sini, 100 kg kat sini, you still akan dapat mu dia sama juga dengan sama juga dengan nilai mass yang kecil, iaitu di sini. So kat sini kita boleh andaikan dan kita boleh summarize. That mean, okay, the coefficient of kinetic friction for a same object. Okay, okay, for the same object, okay, if you put a different mass, it won't change, okay, the kinetic the coefficient of kinetic friction. Maksudnya mass ataupun berat tak mempengaruhi kepada friction, okay, bagi sudut satah condong. Okay, maksudnya coefficient dia tetap you akan dapat sama. Okay, and then syarat dia adalah dia mestilah bahan yang sama. Okay, bahan yang sama. Maksudnya kalau you letak pun 50 kilo pun still dia punya kinetic friction dia adalah sama ataupun mu s dia adalah sama.